In this video we're going to be talking about how to recover from certain errors, how to recover from feed hold and e-stops. So the first thing you're going to want to do in order to be able to recover from these errors efficiently, you have to have your 0 point set. So for starters, I need to reference out my axes. So I'm going to reference out my X and my Y. Okay. This is going to give me my machine 0. So with that machine 0 set, what I can do is zero out my axes, and now I can go jog over to where on my plate I want to start cutting, and I'll set my reference point. So I'm going to jog up and over. And just clear the top of that star and jog over to the edge of the plate. I'm happy with that. I'm going to start my cut there. And so my next step is go to the settings page and set my reference point. Now with the reference point set, I can go back to the run page and zero these out. So now, first off, we're going to talk about e-stops and how to recover from an e-stop error. Generally, I try not to use the e-stop, but sometimes you just got to have the machine stop immediately. If you have your machine 0 set, you can recover from that. If you don't have a machine 0 set, you cannot recover from that, because Mach will instantly lose position once you hit the Z-axis, because it does not allow Mach to finish the line of G-code that it's on. What it does is it stops abruptly, and the buffered G-code that has already been sent out, Mach loses that. So these positions are no longer correct. The difference between e-stop and feed hold is feed hold allows Mach to finish that last buffered set of movements, so it doesn't lose position. So first off, we're going to start out, and we're going to start this cut, and then pretty much right in the middle of one of the cuts, I'm going to hit the e-stop. Okay, and then we're going to go back and go through the process of how do we recover from this. Okay, if this actually happened. Now you could be e-stopping for a number of reasons. Perhaps there was a tip up that knocked your torch off the magnetic hold. Perhaps your consumables, your electrode basically came to the end of its life, and they basically just start kind of spewing out junk, and the cut quickly goes downhill. It could be for a number of reasons. Perhaps someone's hand got too close to it. Perhaps, someone's something got caught on the rails or something like that. Perhaps the x-axis actually, your bearings ran into something, you notice they stopped. All right. Anytime that happens, you're losing position anyway, so you might as well e-stop. Generally, for things like tip-ups and loss of my consumables, the end of life of the consumables, I try to use feed holds because it's a little bit quicker to recover from them. So we're going to start this cut, and then I'm going to e-stop it in the middle of probably one of the first cuts. Okay, so I e-stopped it. Basically, at this point, your positions up here are not correct. Okay? So, really the first thing you need to do to recover from an e-stop like this is go back to your machine 0 so you can get back to your set point, or what was your part 0. Okay? And once you're back at the part 0, we can go back through the G-code and get back into the correct position. So the first thing you need to do generally is I make sure my Z-axis is not too close to the plate. So I usually raise it up that far. So, and then I'm going to reference my X and then reference my Y. By doing that, I'm getting back to my machine 0. So now we are correctly back to machine 0, and I can zero out my axes. Okay. Now, once I'm back to machine 0, I can go to my settings page and click go to my reference point. One thing I want to notice is the Z-axis position. It's set at 0.12. It's really close to the plate. If I go back to here, you'll see I'm an inch higher than that. So that means the Z-axis is going to drop down 1 inch before it starts to move. I don't really want that. To make sure that doesn't happen, I'm going to zero this out right now. Okay, so I know that my torch is not going to drop down and potentially hit the plate. So back to settings page, I'm going to hit go to reference point. So now we're right back to where we started out the cut. Okay, now I can go back to program run and zero out my axes. And now I'm right back to where we started the rapid from. And so what we want to look at now is, this is where it comes in handy to be able to scroll back down through the G code and watch the movements. Basically, we lost it on that line of G code. Okay. Usually what I like to do, and I find it easier to do this, is to go back to the last pierce. Okay? You know, this could be... So, since there wasn't a pierce before that, it's actually going back to the very beginning. Okay? So from this position, I could run it from the very beginning and it would start back up. It would overcut this part of the cut that's already been done. However, usually that's not a big problem. Particularly on thinner materials like this, usually you can get away with it. A lot of times what I'll do for that is turn my torch height control off, particularly if it's a long cut. Because being that the cut's already there, the voltage is going to be higher than it should be, and you're going to run the risk of diving a torch into the plate. So what I'm going to do to finish this cut and keep going is I'm going to rewind the G code, okay, back up to this last, normally I would rewind it to the last, to finish the last cut, but since there is no finish to the last cut, I'm going to rewind it all the way, okay, back to the beginning. And I can run from here, okay, I can basically just hit run and it will finish my cut. But to do that, I'm going to turn the torch height control off initially, okay, until right before, actually on such a small cut I really don't need to, but I'll do it anyway, until I start to see it get into fresh material, and then I'll turn it back on. So we're going to hit run and finish this cut, and then I'm going to show you how to feed hold. So what I'll do is I'll let this cut happen, then it'll cut here, and then I'll feed hold on the rapid in between, okay? And this is going to show us, you always want to try to feed hold on your rapids rather than feed holding on a cut itself. So I'll show you what that looks like. So we're going to let this cut finish. It's going to cut this one, and then I'm going to feed hold on this rapid in here. Okay, so we're going to hit run. And as soon as I start to get towards fresh material, I'm also going to turn the torch height control on. So. Okay, so I feed held the machine in between these on this rapid right here. Okay, so that's the best time to feed hold your machine. If you ever have a problem with tip-ups or really anything, if you can avoid not doing an e-stop, not feed holding during the cut, and solely feed hold on the rapids, you're going to save yourself a world of trouble. Because at this point, I can come over here, fix a tip-up if there was a tip-up. I could take my torch off, replace my consumables, do whatever I need to do, clean off the rails if there's something in the way, and then I can simply hit run, and it will pick up from where it left off and continue cutting. Okay. Now, however, if I feed hold while it's cutting, you're going to see what will happen is it will feed hold and will stay in the right position. However, the torch will not turn off automatically. You will have to manually feed hold and then turn the torch off. Okay? Generally, what that's going to mean is you're going to end up with a divot where the torch paused and burned away too much material. And that can cause, it just won't look good. So that's the reason you want to avoid feed holding like that. But we're going to do that. I'm going to feed hold it during the cut just to show you what that looks like, and then I'm quickly going to turn the torch off. Okay, so here we go. Okay. So I feed held. The machine's in the correct position because I feed held it. I did not e-stop it. So I don't have to, at this point, go back to my machine zero because I still have not lost position at this point. But what I do need to do is finish that cut. There's a few ways that you can do this. Usually, at this point, what we're going to need to do is back up the G-code in order to get back to this pierce, this initial pierce right here, okay? So normally what I would do is I like to back all the way up to the end of this last cut right here. And you'll get to recognize this G-code in here. And really what you're looking for is this set of G-code from M5 to M3. Okay, this is your pierce G-code. Okay, this is the torch being turned off from the last cut. It rapids up to 2 inches high. It moves to the next cut, and then it goes through its pierce sequence where it drops down, it feels the plate, it zeroes out, it goes to pierce height, and then it drops to cut height, and then it goes to pierce height, then turns on the torch, and then starts cutting. Okay, so basically what I'm going to do is rewind back up till I'm at that M5, which is that end of that last cut, which is right there. Okay, and so by rewinding, I'm putting that line of G-code in this little white box here. Okay, and now what I can do is I can hit run from here. Okay, and what that's going to do is Mach's going to go back through, run through all the G-code until it finds this position, and it will create a go-to move that will allow me to get to that point and restart my cut. So I will hit run from here. Now, you couldn't really see it very well, but if this is a longer G-code, this went negative, and you'll see this continue to go negative. Because of the pierce routine, this automatically slowly starts going negative as Mach is running through the program. So if it's a long program and you say had an error near the end and you have to run all the way back through the G-code, like I'll do it again. You can see that go negative. Okay, so it keeps going negative. So that can pose a big problem for you if you try to do your cycle start preparation move without fixing this. The first thing you want to do is zero this out. with that zeroed out, now I'm ready to press my cycle start for preparation move. It's telling me right down here. Okay, this is going to pull up the coordinates and the height that's going to use to transfer at. So I'm going to click OK. It's going to move to the end of the last cut, which is right there. Okay. Now I'm ready to just cut from here. Okay. Usually what I would do is just run from here, particularly on such a small little cut. I may sometimes do what I did last time, which was turn the torch on only when it got to, or turn the torch height control off and then turn it back on when it gets to fresh metal. But I'm going to leave the torch height control on just so I can show you how that works. My suspicion is that it's not going to be too much of a problem. My guess is the tip saver is going to prevent it from diving, but I could be wrong. So we're going to do a little experiment here and hit go. And then I'm going to feed hold on the transfer to the next cut. Okay, so I'm going to hit run. Now, as you can see, it took a really long time for the arc good light to come on. That was because the cut was already there. So sometimes it'll catch really quickly and you won't have any problems. However, in this particular instance, it took a really long time for that arc OK signal to get thrown. For the arc to throw correctly and for Mach to start moving. If I had turned the torch height control off prior to making that initial cut, I could have done exactly what I did the time before, which is turn the torch height control back on, or just let it run with the torch height control off until it's up and running correctly. And that would have prevented it from pausing for such a long time on that initial pierce. So I've feed held it again. Okay, it's ready to drop down and pierce and make my next cut. So basically, what I'm going to do. So what we've talked about here is to essentially how to recover from an e-stop and how to recover from a feed hold. Whether that feed hold is actually feed held on the material itself or feed held on the transfers between. So at this point, I'm just going to let it cut the rest of the star out. And if you need to rewind this video, review it. I know there's a lot of information. Any questions, give us a call. Learning the basics of recovering from these different types of errors is key to really be able to. It's going to save you a lot of material, basically, is what it's going to do. So, okay, I'm going to hit run. So, you notice that it did it again. It cut out my torch mid-cut, then turned it back on. One more reason, never use Windows 7 to try to run your plasma cutter. There are just too many quirks in it. And that's that. And, there's just one more reason also. You want to have as little running when Mach is running as possible. Because, having screen capture software and HD video camera is probably giving me some problems. So,